44.7 million of metric tons of e-waste were generated around the globe in 2016. This is an equivalent of 4,500 of Eiffel Towers. Indeed, across the world, in both developed and developing countries, we are throwing out ever-increasing quantities of electronic and electrical waste. Vast amounts of used and end-of-life electrical and electronic equipment are shipped around the world, and sometimes illegally, often ending up in developing countries that lack the infrastructure to manage them properly. Let's have a look what is going on in one of the developing countries, Ghana.
This is Agbabloshi, a suburb of Accra, the capital of Ghana. But local residents have given it a nickname, Sodom and Gomorrah. It's the home of the biggest electronic waste dump and is a livelihood for many. First it feeds them, then it kills them. This is one of the most polluted areas with toxins and toxic metals on the African continent.
As you have seen from the video, the components that cannot be recycled due to lack of facilities are burned or dumped. Such globalization of e-waste has adverse environmental and health impacts. In today's presentation, we are going to explore the risks of e-waste posing to the environment and health, its management, movement and trade, legislation and possible solutions. Before we move on to the main part, let's respond to the question, what is e-waste? Well, electronic waste or e-waste refers to all items of electrical and electronic equipment and its parts that have been discarded by its owner as waste without the intent of reuse. E-waste is also referred to as waste electrical and electronic equipment. Electronic waste or e-scrap in different regions and under different circumstances in the world. It includes a wide range of products, almost any household or business items with circuitry or electrical components with power or battery supply. It covers 6 waste categories, as you can see from this slide: temperature exchange equipment, screens, monitors, lamps, large equipment, small IT and communication equipment. They all refer to different types of equipment, including refrigerators, freezers, air conditioners, monitors, laptops, notebooks, high-intensity discharge lamps, LED lamps, clothes dryers, dishwashing machines, cleaners, microwaves, ventilation equipment, toasters, calculators, video cameras, global positioning systems, and many more. Each product of the 6 e-waste categories has a different lifetime profile, which means that each category has different waste quantities, economic values, as well as potential environmental and health impacts if recycled inappropriately. As you can see from the map, Australia, China, the European Union, Japan, North America and the Republic of Korea produce most of the world's e-waste, while the developing countries from Global South receive the most global e-waste. The illegal movement of e-waste from developed countries to developing countries is a major global challenge today. So this map shows inequality between developed countries and developing ones, leading to environmental injustice for those marginalized ones.
After discussing global e-waste distribution, let's move to e-waste recycling. As shown in the picture, globally, society can only deal with 20% of e-waste appropriately, and there's little data on what happens to the rest. The most part of this undocumented waste ends as in landfill or be informally recycled, including burning, shredding, and dumping. When it comes to health impacts by e-waste, some of the more affected organs from this issue are our brain, kidney, liver, skeletal system, and heart. In the rare cases, it can even damage our reproductive and nervous system, especially to the ones who directly exposed to this waste. This can end in people with birth defects and diseases like cancer, and the highly affected people are informed and former recycling workers and populations living in contaminated areas. E-waste threats to the environment and to human health come from three groups of substances that can be released during recycling and material recovery. And they are the original constituents or equipment such as lead and mercury, and substances that may be added to separate and altered materials such as cyanide, substances such as dioxins that may be found and released by unsound recycling operations such as uncontrolled burning process or open burning. Turning to the harmful effects of e-waste on the environment, you will need to be aware of the negative impact on the air, soil, and water. When you burn electronic products, this waste can release hydrocarbons and dioxins into the atmosphere that can cause air pollution. In addition, e-waste in regular landfills or in places where it is dumped illegally contaminates soil and groundwater, put the food supply system and water sources at risk. On top of that, every device ever produced has a carbon footprint and is contributing to human-made global warming.
Next, I will explain how to manage e-waste through the case of China, because China is the world's largest e-waste disposal country. Also, it now appears to be the largest e-waste dumping site in the world, receiving shipments from the US, Europe, and neighboring Asian countries, including South Korea and Japan. So we focus on the e-waste management in China. First of all, a great variety of electrical and electronic products has been put on the domestic market. In China, the importing of e-waste was formally banned by the government in 2000. However, a remarkable amount of e-waste is imported to meet the demand for second-hand equipment and for secondary resources. New electrical and electronic equipment is being produced at ever greater rates to replace older equipment. When replaced, this older equipment will either be stocked temporarily or will become e-waste. These e-waste are taken to reuse market. Both the formal and informal sectors participate in the collection of e-waste in China. Once the material has been collected and undergone a simple sorting and classification process, there are usable second-hand appliances and valuable components that have been collected are sold to the local second-hand market or exported to other countries. Formally processed e-waste is cleaned of toxic materials, but the informal e-waste is unclear. Those items with little or no reuse values are exported or sold to scrap dealers for the value of the remaining material. Finally, residuals are incinerated or landfilled in rural areas.
Here we can see waste generation classified in regions for year 2016. The biggest amount of waste is generated in Asia, but the biggest amount per person corresponds to Europe and Oceania. Here we can have a better idea of how e-waste is produced in several countries. As we can see, the e-waste generated per citizen of the UK is 18 times that of Nigeria, one of the main receivers. It is also remarkable that the United States, one of the biggest exporters, is the only developed country which did not sign the Convention of Basel. It is very hard to know what the final destination of e-waste is, since many of the exports take place informally and illegally. One of the main methods is to track via GPS. An experiment conducted in the US in 2016 showed that more than one-third of the waste was exported. Almost all of it went to developing countries in Asia, but some of it went to Mexico and Canada. Typically, transboundary e-waste movement occurred between the developed countries and countries in the Asian region such as India and China, where disposal facilities are cheaper and environmental regulations were less strict or poorly enforced. As e-waste-related laws were implemented in these countries, the West African market consolidated as a promising alternative, being Nigeria and Ghana the biggest importers. The electronic and electric equipment trade is operated by diverse actors, ranging from small family networks to big trading firms. This equipment can be highly valuable, with 90% of its value accounted for the gold and the palladium contained. Other valuable elements are silver and copper. E-waste travels mixed between used electronics, frequently under the name of second-hand goods, This is a common way to dump waste far from the country of origin and opens an irregular market that has severe impact on both people and environment. However, the recycling of used electronics is a source of high income for many of these spots, which makes it a double-edged sword. One of the challenges of West Africa is to stop importing e-waste without affecting the used electronics obtention, so as to improve recycling systems to face an increase in domestic production.
The legislation covers about 2/3 of the global population. As you can see from Table 1, the sub-regions where e-waste legislation is most developed are found in Europe. In Europe, the e-waste amount documented to be collected and recycled are also the highest. Other countries with developed e-waste recycling and collection are in the Northern America, Eastern Asia, and Southern Asia. In several regions, national e-waste legislation is completely absent, such as in a large part of Africa, Caribbean, Central Asia, Eastern Asia, and Macedonia, Polynesia, and Micronesia. Additionally, the types of e-waste covered by legislation differs considerably across the countries. This is also explained that difficulties in coordinating collected and recycled e-waste amount. Many of the countries that have already adopted e-waste legislation can still increase the coverage to include all products. For example, in the US, the consumer electronic products included in the EPA report series are electronic products used in the residence and commercial establishments such as businesses and institutions, and are categorized as video, audio, and information products. So many electric and electronic appliances are out of scope in the USA, such as all cooling and freezing equipment, mass large equipment like dishwashers, dryers, etc., some small equipment, and lamps. When it comes to the export of e-waste to developing countries, it is regulated under the Basel Convention on the Control of Transboundary Movement of Hazardous Waste and Their Disposal, which has been ratified by 188 countries. Other similar conventions exist at a regional level. Even with the convention in place, however, large amounts of e-waste continue to be shipped illegally. For example, 1.3 million tons of discarded electronic products are exported from the EU in an undocumented way every year. The illegal movement of e-waste from developed countries to developing countries is a major global challenge. There is a complex web of transshipment parts so that e-waste avoids detection by authorities. Most legislation and policies currently refer to the principle of extended producer responsibility, which emerged in a document circle in the early 1990s. It is generally seen as a policy principle that requires manufacturers to accept responsibility for all stages in the product's life cycle, including end-of-life management. There are three primary objectives of the EPR principle. Manufacturers shall be incentivized to improve the environmental design of their products and the environmental performance of supplying those products. Products should achieve a high utilization rate. And the third, materials should be preserved through effective and environmentally sound collection, treatment, reuse, and recycling.
As my colleague mentioned, responsibility should be at the individual and collective level. In order to reduce e-waste, we should conserve resources and reduce the amount of energy we take from the earth. We should reuse the precious metal and plastic in old phones alone instead of making or mining more of them. Would save as much energy as flipping off the power of 24,000 American homes for an entire year. Also, the typical American household has 24 electronic devices, and in 2009, the EPA estimated that there are 2.37 million tons worth of electronic ready to be disposed of. Imagine, this alone would fill almost 5 football stadiums. It is quite insane to think about it. We should also reevaluate. Do you really need that extra gadget? Try finding one device with multiple functions. We should extend the life of our electronics. For instance, we can buy a case, keep our devices clean, and avoid overcharging the battery. We can also buy environmental friendly electronics. Look for products labeled Energy Star or certified by the Electronic Product Environmental Assessment Tool. We can donate used electronic to social program and help, for instance, victims of domestic violence, children's safety initiative, environmental causes, and more. You can also, in a schools area, ask your student representative for postage paid mailer for your cell phone or in cartridge. For each item received, the World Wildlife Fund will receive $1. You can reuse large electronics. You can recycle electronics and battery in e-waste recycling bins located at different places. Large electronics can go in the larger bins found in your building. We should also raise awareness on the danger of e-waste on the population, health risks associated, and the environment. We, the consumer, have a say too. We can pressure electronics companies to change their behavior by boycotting their products or rioting. We can also, countries, pressure the West to better care of their waste, to recycle it, and to do not dump it illegally in the South. Humiliation or shame is also a great incentive to enforce regulations.